we're going to look at solving a two-variable system by matrices. When we're done, you'll find that the solution of any system by matrices using a calculator is elegantly simple. Well, let's start with this one. 3x plus 5y equals 35, and negative 2x plus y equals negative 6. The first thing we'll note is that we can rewrite any system as a matrix equation. We take one matrix is of the coefficients times a matrix which contains our variables equals, and then a matrix which contains our constants. And you'll note that if I multiply 3 times 5 times xy, I get 3x plus 5y. And if I do the second row, negative 2 and 1 times xy, I get negative 2x plus y. So these two do multiply to give those two. Now, what we've learned in mathematics is that if I have an equation and I want to get rid of something, what we do is we use the inverse. So I'm just going to demonstrate that we would use the, I'm going to call this A, and this B, and this our M for matrix. So we have A, M equals B. What we're going to do then, to cancel out the A's, we're going to use A inverse on both sides. These two will give us the identity matrix, which gives us M equals A inverse times B. So now that you see, what I'm going to write next then is M equals A inverse times B. So M xy is equal to 3, negative 2, 5, 1 inverse times 35, negative 6. So we should already know how to write the inverse of a matrix. I'm just going to go ahead and write equals, and then we'll do that. The first thing I need to do is find the determinant. So the determinant is 3 minus a negative 10, which is 13. So the inverse is going to be 1 over 13. Remember, we switch these two, and we make these opposite. And that will equal, according to the rules, a 2 by 1 matrix with E. And so now we need to calculate what those two entries are. This is first row times first column, so that's the first row of this matrix, 1, negative 5, times the one row in the constants, 35, negative 6. Multiplying these together, we get 35 plus 30, which is 65. So E1 is now 65. And don't forget we have the 1 over 13 out here. Now to find E21, I'm now going to use the second row to 3 times our constant, 35, negative 6. And this is 70 minus 18, which is, I believe, 52. Now we multiply by 1/13, and we get 5 and 4. This tells us then that x equals 5 and y equals 4. Very smooth, no thinking required, just following the matrix operations. Let's do one more, and then I'll make some observations at the end. Let's do this matrix. 2x plus 5y equals -11. And then we'll do 3x minus 2y equals 12. So this means that x, y will equal to the inverse of this coefficient matrix, and we'll just go ahead and do that kind of in our head. We'll swap these two and make these two opposites. And now we'll find the determinant. The determinant is -2 minus 15, which is -17. So I have -1 over 17. Now, it's just my philosophy on this, that when I have a negative fraction out front, I'm going to make that positive by multiplying the -1 on the inside. So this will become positive, and these will all change their signs. That just makes work a little easier when you get to the end. You don't have to do that, but that's just something that I do to make my numbers easier. Okay, that's going to equal, we're going to take the first row times this column, so that's 2 and 5, -11 and 12. This is -22. This is 60. 60 minus 22 is 38. No. Yes. I made a mistake on the determinant. That's what my problem is. Okay, so this is equal to 38. And I calculated my determinant incorrectly. Let's redo it. -2 is, times 2 is 4 minus 15, which is -19. So this was 1 over -1 over 19, and we made it positive. I'm glad I caught that mistake. I don't have to redo the whole video over. Okay. And the second element is 3, -2 times -11, 12. It's -33 and -24, which gives me -57. Well, dividing by 19 gives me 2 over -3 in my matrix, which means that x equals 2 and y equals -3. Very elegantly done. Just have to do your arithmetic correctly. Now, I want to make some observations. Once we've done 2 by 2 and you have a calculator, any system of equations, no matter how large, can be done by following the pattern we have in the matrices. We have the coefficients matrix, which I'll call A, times the variables matrix, which I'll call M, equals the constant matrix, which I'll call B. And so to find the solution, I simply cancel A by using its inverse, and so I have A inverse B. This solves all systems using a matrix calculator. Right here. So you see the solution of all systems of equations. This is a very elegantly simple way to solve any system of equations.